So today we are going to see the relation between the electric current and drift velocity. So நம்மளுக்கு முன்னாடியே தெரியும் ஒரு கண்டக்டர் இருக்குது அப்படின்னா அதுக்குள்ள எலக்ட்ரான்ஸ் இருக்க போது அந்த ஃப்ரீ எலக்ட்ரான்ஸ் தான் வந்து கண்டக்டரில் இருக்க கண்டக்ஷனுக்கு யூஸ் ஆக போகுது அண்ட் அந்த ஃப்ரீ எலக்ட்ரான்ஸ் என்ன பண்ண போகுது இந்த ஆட்டம்ஸ் மேலே மோதி ஒரு drift velocityல மூவ் ஆக போகுது ஓகே ஸோ we are going to consider a conductor which is being connected to a battery. So let us have positive negative. So the current is going to flow in this direction and this is going to be the current which is going to come out. இப்போ நான் இந்த கண்டக்டரோட லென்த்தை வந்து let me consider it as L and let the area of the conductor be A and the free electrons be E. Okay. So the electrons are going to always travel from right to left end, correct? So with the drift velocity Vd, right? So basically there is going to be an electric field across this when we are supplying this conductor with a potential V, right? So it is going to be V by L. So due to this there is going to be some movement of electrons which is going to hit the atoms in between and going to get drifted with some velocity called as drift velocity. Okay, right. So now we are going to find the relation between the electric current and the drift velocity which is going to be present inside the conductor. Now let us consider the number density or the number of electrons per unit volume of the conductor as n. Okay, so let n be number of electrons per unit volume, or we can also call them as number density, right? And the charge of an each electron, let it be q, right? If I want to know what is going to be the number of electrons present, why? Because basically we are going to find out what is going to be electric current. Electric current na yaar namalukku theva q um t um theva, correct? So q you know it is going to be ne, but I want to know what is going to be the number of electrons present inside the conductor which is helpful for electric current. Appo என்னன்றதை நம்ம number of electrons per unit volume எடுத்துருக்கோம் கரெக்டா இப்போ I want to know what is going to be capital N which is nothing but number of electrons. So this can be written like what? Number density into volume, right? Because per unit volume and volume, if I am multiplying it I will obviously get this. So appo N into, you know what is volume, right? A into L, area into length is going to be the volume. Appo AL. So appo NaL is going to be the number of electrons. And I require Q, right? So appo Q is equal to N into E, right? So from this I can replace this N as NaLE. So this is going to be Q. So we have got Q here, right? And also we want to know what is going to be time. So time என்றது என்ன பேசிக்கா இங்க இருந்து எலக்ட்ரான் இவ்வளவு தூரம் டிராவல் ஆக போகுது கரெக்டா அதுக்கு எவ்வளவு நேரம் எடுத்துக்குது so obviously you know time is nothing but what பேசிக்கா velocity is nothing but displacement by time, correct? So appo time is going to be displacement by velocity, correct? Here the displacement is going to be the length of the conductor which is going to be L by the velocity is going to be drift velocity. Okay, so now you know what is going to be T and you know what is going to be Q. So can I substitute that in I? So I is equal to what now? Q by T, where Q is going to be NaLE whole divided by L by Vd. So LL cancel. So denominator of denominator goes to numerator here. So it will become NaEVd. So this is going to be the relation between electric current and drift velocity. And also when you bring this area down here, so it will turn out to be I by A, which we normally call them as current density, and this can be written like NeVd. So this is nothing but the relation between electric current and drift velocity.